Okay, so the other type of inequalities that we have are quadratic inequalities that are only in one variable. So when you think about a quadratic inequality like we did last time, where it's got a region that's shaded, that shaded region is the set of all of the points that make the inequality true. And the points are all given by x comma y. And the reason that happens is because you have y, just y. You have y is, for this one, we'll say greater than or equal to x squared, and then whatever the rest is. Your original problem has both a y and an x. When we're talking about quadratic inequalities that happen in only one variable, we're not going to be using that y anymore. So instead of having y is greater than or equal to, we're going to have x squared plus x minus 6 is something like less than or equal to 0. So instead of having a y, now we're only going to be talking about x values. So our answers are going to be just for x values. And the reason that the way that we're going to do this is we're going to find the x-intercepts, but we only want the x-coordinate of it. So instead of the x-intercepts, that's called the zeros. It's just the x-coordinate of the x-intercepts. And that's where we're going to start. So the way that we find those are by factoring or using complete the square or the quadratic formula. And the easiest one that we're going to have for that is factoring. So hopefully the ones that we're going to be doing right now are going to factor. If not, we'll move on to another method. So looking at our first step, we want to find the zeros. So to do that, we're going to take this inequality and we're going to figure out where x squared plus x minus 6 is actually equal to 0. And that means we're going to be looking for the way that it's going to factor. So that x squared will break up into x and x, and the minus 6 will break up into 3 and 2, with 2 being negative. So our zeros here are what we get if we set each factor equal to 0. So we have our zeros. We've done this first step. The next part of this is going to be using a number line. So our number line is going to contain the points -3 and 2. And at those points, our graph is actually 0. That's where the parabola would be equal to 0. Now you only have two options for a parabola. You can have a parabola that faces up or a parabola that faces down. If it faces up, you know that the a value is positive. If it faces down, the a value was negative. So in our graph, our a value was a positive 1. So that means that our graph would look like this. So we're going to take and imagine that that graph is really in here. And so here would be our imaginary graph. It's facing up. It goes through the x-axis at the points -3 and 2. And what we're going to be trying to determine is whether we're positive or negative when we're on the left, the right, and in between. If the graph is above the number line, that means it is positive. If the graph is below, that means it is negative. So if we look at what we're doing right here, we've got a positive to the right of 2. We also have a positive when we're to the left of -3. When we are in between those two numbers, we are below, so we are negative. That means that we can take, we can take this, and if we imagine that that graph wasn't there, we have 0, plus, minus, and plus. So we are only interested where our graph was less than or equal to 0. So here are the places where it's equal to 0, and it is less than when it's a negative. because negative numbers are less than 0. So it's going to be in between. The way that we're going to write our answer is an interval. And so our final answer would be the interval from -3 to 2. And since it's equal to, we're going to use brackets. This would be the answer that we would be looking for. If it had not been equal to, we would use parentheses. So for example, if it had just been less than, your answer would have parentheses. If it had been less than or equal to, your answer will have brackets. And this is one example that we have for quadratic inequalities in one variable. We're going to do one more example. Okay, so in our second example, the big difference is that the number on the end over here is not 0. In order for us to be able to solve these inequalities, the number on the end actually has to be 0. And the way that we can fix that is just by adding that 15 over to the side with everything else. So we have -x² plus 2x plus 15 is less than 0. And so our steps are still going to be the same. We're still going to try and factor. If we can't factor, we're going to have to complete the square or use the quadratic formula. So hopefully it'll factor. If not, we'll be okay. And then once we've done that, we're going to use the number line and the signs. So we're going to call it a sign line. So what we're going to do is start by trying to factor. And the easiest way, if you have a negative out front, would be to factor out a -1. So that's going to change this to a +x², a -2x, and a -15. And so we have a negative out front, and then this thing's going to factor as x and x, and then 3 and 5 have a difference of 2, so we'll put in our 3 and our 5, and since we have a -2 right here, that means the negative should be with the 5. So we're going to try and figure out where that's actually equal to 0, so that means we're going to be looking at each factor being set equal to 0. So we have -3 and we have +5. Those are going to be the points that we put on our sign line. So -3, +5, and remember that that is where the sign is actually 0. Now your A value, you need to go back to the beginning for this one. You could look at it at either of these steps. Your A is -1. That means that your graph is going to face down. So we're going to put in our imaginary parabola right here to help us figure out what our sign should be. So to the left of -3, our graph is below the line right here, which means that it is negative. Between 3 and 5, our graph is above the line, which means that those are positive values. And after 5, it goes back down below, so it's negative again. So our overall sign line looks like -0, +0, negative. And we are only concerned with the places where it is less than 0. Negative numbers are less than 0. We don't want to include the -3 and the 5 because that's where it's equal to 0. But we do want to include everywhere that it's negative. So we would like to include everything on the outsides. Now this interval is going to be a little bit different. The smallest value out here, that arrow means it goes on forever. It goes on until it approaches -infinity. That's as small as we can go. So it goes on forever. So it's going to be negative all the way until it gets to -3. And since it's not including that, you're going to use a parentheses. And then we have a different set over here where we start at 5 and we keep going on and on forever until we get to positive infinity, which we'll never reach. But that shows us that it's going to continue to be negative forever. Now to link these two sets, we either want to be from -infinity to -3 or 5 to infinity. This symbol is the symbol of union, which is the symbol for or in interval notation. So that's going to be the symbol that we're going to use. You are always, always, always going to use parentheses when you're talking about negative infinity or positive infinity. You will never use brackets because you can't ever get to infinity. So that is something that you never want to do. You're always going to use parentheses when you're talking about the infinities. Even if these ones on the inside with the 5 and the -3, even if those had been brackets. But this would be what your answer would look like, and you would be done with this problem. So hopefully that was helpful.